Hello, and thank you for tuning in. This is my talk on designing APIs for humans. But first, a little bit about me. My name is Paul Asjes. I am a developer experience engineer working for WorkOS, and I am based in Amsterdam. So today, I want to talk about several things. I have a little agenda for you. I'm going to start off with talking about what designing for humans really means, what I mean by it. We're going to talk about object IDs. I'm going to talk about error messages and why you suck at them. And we're going to kind of close things out with talking about design patterns. But let's start with the subject of the talk, which is designing for humans. Now, what exactly do I mean by that? And I'm sure some people are already asking, but thinking to yourself, like, well, designing for humans, what's the point of that? Aren't we designing APIs for computers? Aren't they for machines? Isn't that what an API, a application programming interface, really means? And I would say, well, yes, that is true once an integration is complete. However, who are the ones actually doing the integration of those APIs? And I would argue that the ones that are doing that for now anyway are the humans behind it, the developers who are actually the ones building your APIs or building integrations on top of your APIs. Now, maybe in the future, when ChatGPT gets really good, this might take it out of our hands somewhat, but humans are definitely the ones going to be doing the debugging, and I'm pretty sure of that. Anyone who has used Copilot or ChatGPT for code knows that you can't really just copy and paste stuff into production. You do have to do a lot of debugging. So there's a lot of room here for humans to still be very required in this process. So designing for humans really means that when you're building and integrating your APIs, that you're thinking of the human behind the process and what makes them tick. Let's start off with object IDs to kind of demonstrate what exactly I mean by this. Now, what is an object ID? Let's start with just a very simple example of a user table in your database. So let's say you have this user table, you've got a first name, a last name, and an email. Database 101 is that you need some sort of primary key or an ID to be able to refer to each one of these rows if you want to retrieve them later. Now, in this particular table, can't use first name or last name because those are not unique. And you don't really want to use email either because that can change. Like if someone wants to update their email, some of your ID changes. So a reasonable solution would be, okay, let's just add an ID and just make it be numerical, and it just increments every time we add a new user. Now, this does have the advantage of making it very easy to talk about your users. It's very easy to say, hey, can you check out user number 3 or order number 5 or whatever like that. But the problem with this, that if you are planning on making this data available publicly, so via your API, then this process, this enumeration right here, is actually extremely dangerous because this leaks information about your company and about your API that you probably don't want people to know about. To give you an example, if I am a customer of your service and I buy something from you and I see that I have order number 7, well, this tells me a lot about your company. This means that you've only had 6 orders before me, so perhaps you're not as big as I thought you were. And it also tells me that it means I can guess the ID as well, what's going to be the next one. Since I'm order number 7, I know that the next one's going to be order number 8. And if you haven't secured your API correctly, which I hope that you are, I might be able to get information about other people using your service based on these numerical IDs. Now, if I can't guess the ID, that would make it very difficult for me to do that. But since I can, I'm able to potentially retrieve information that I shouldn't. And also, for instance, if I'm like an investor and I'm checking out your service and I see that I'm only order number 7, I'm probably going to rethink whether I want to invest in someone at such early stage. You're leaking information about your company that you really don't want people to know at this point. So numerical IDs may be the best idea. What can we do to improve this? What about something like the UUID? Hopefully everyone's familiar with these, the Universally Unique Identification. The great thing about these is that when you generate them, the chances of a collision, which is that 2 IDs generated are exactly the same, is so vanishingly small that it might as well be impossible. So you're never going to have a kind of duplication, which is great. The downside about this is that it's a mouthful. It's hard to talk about IDs and it's hard to query IDs when you have this huge ID setting here. So for instance, if I say I want to talk about user 251CA967, blah, 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 it's very difficult to do so and not very human legible. So let's talk about how can we fix this? How can we have like a better ID that makes everyone happy, is both unguessable and can be used by humans as well? Well, the answer, let's look at how Stripe does object IDs. If you're not familiar, Stripe is a payments company. If you wonder why I'm talking about Stripe, I actually worked for Stripe for 5 years before I started my current job at WorkOS. But all the stuff that I'm talking about, we do at WorkOS as well. Now let's talk about how they do their object IDs. Now you notice here in this example, we've got something called a prefix, and then we've got the randomly generated characters. The prefix is anywhere between 2 to 5 characters, followed by an underscore, followed by these random ID. And what this does, this prefix, its purpose is to make this object ID be human readable. This in particular is an ID that refers to an organization object. And I know that because it says org in front of it. Similarly, if it had something like payment intent or user, it would have a similar prefix in front of it. To show the power behind this, let's look at a code example from the Stripe Node SDK on how to create a payment intent. So I am creating a payment intent. I pass in the amount, the currency. Then I have to pass in a customer and a payment method. A payment method in this case being the instrument we're going to be using to actually make the payment. Now, already looking at this, I can tell you that the customer ID is correct because it begins with CUS underscore. And similar with the payment method. If I was using something like a UUID, I would have to double check that the ID that I copy and pasted is really of the object type that I'm looking for. Whereas here, with project prefixes, I can immediately see that I've done this correctly. This also really helps with debugging. So for example, here is a real code example that I got at my time at Stripe from a user. This person is trying to retrieve a charge, but they're passing a second object over there, which says Stripe account and then an ID. Now, what they're trying to do is retrieve a charge on someone else's Stripe account, which they can connect to via the Stripe Connect product. Now, immediately, without knowing anything about this particular user's business, about their code, about their stack, I can immediately see the problem is that they are passing in a customer ID instead of an account ID. An account ID starts with ACCT underscore, whereas a customer ID starts with CUS underscore. Again, I know nothing else about this user. I don't know anything about the customer or the charge or the account they're trying to retrieve, but I can immediately see they made this mistake. So this turns from like a 10-minute debugging process to like 2 seconds. So the case for object ID prefixing is that it makes it human readable, it helps prevent bugs, and something wonderful called polymorphic lookups. Let's dive a little bit more into that. So polymorphism in APIs is when you have a single field that can represent multiple object types. Going back to our example from earlier about creating a payment intent, you'll notice that here in this example, in the field for payment method, I'm passing through something that does not have the usual payment method prefix of PM underscore, but something else called card underscore. This is a card thing. Now, the reason for this is that Stripe built the payment method API as a drop-in replacement for the older card and source APIs. But for backwards compatibility reasons and users that still had using the old APIs, we had to make sure that this new API worked with the old stuff, which means that when you create a payment intent, you can actually pass in anything from a payment method, a card, or a source ID, and they will all just work. But if you think about it for a second, this actually presents some difficulties. So if I pass in a card, for instance, here, a card ID, now instead of only looking up in one database, which is the payment method database table, I now have to search 3 separate tables to find this ID. But with our prefix, I don't have to do that anymore. Now I know exactly which table to look for it. We could recreate this with like passing in a hash like this, for instance, where we pass in a type and then an ID for this polymorphism. But the thing is, this adds unnecessary complexity to our API. Rather than passing a simple string, we're now looking to pass in a hash, which means we've got 2 more fields. There's more chance of this going wrong. Instead, it's much easier just to kind of contain all of this into a single string ID, where we can extract all this information out in one easy go. And it makes it much quicker as well, because now we only have to look into one, like I said before, only one database table rather than looking at 3. Going back to the ID I talked about before, I was actually lying. There's more going on under the hood than just randomly generated characters. And there's something called database sharding, if you're not familiar with it. This idea is that if you have a table in a database which is absolutely massive, millions upon millions of rows long, perhaps what you want to do to speed things up is shard your databases and splitting them up into small little pieces. When you do that, you need something called a shard key, which refers to the exact database shard that this particular object lives in. So if you break down the ID once more, we've got the prefix, which tells us this is a payment intent. It goes in the payment intent table. We have the shard key, which tells us exactly which shard to use. And then finally, those randomly generated characters serve as their kind of primary key ID within the database to find this object very, very quickly. So again, the case for object ID prefixing, it's human readable, helps prevent bugs, polymorphic lookups, and it can speed up your lookups by an order of magnitude as well, because you know exactly where to look. Next up, let's talk about error messages and why they can really suck. Presented to you here is an actual error message that I have received in the real world production environment. Now, I won't name and shame where this came from. What I will say is that this came from a large financial institute, which gives you an idea. So what's wrong with this? Lots of things. The main thing's probably the fact that it says status 200. Now, 200 status means everything's fine, but clearly everything's not fine because in the body there's a message that says error. However, that's all I can glean from this. There's nothing else that tells me whether this is actually a problem or not. Status says one thing, message says something else, and now I have no idea what is going on. This is completely useless. I have 4 rules when it comes to building out your API errors. 1, send the right code. 2, be descriptive. 3, be helpful. And 4, be empathetic. And I'll go through examples for all of these, but the idea is that if you combine all of these, you build something in your error messages which is actually useful to the humans behind the API. This is going to make turn your API from a okay API to a great API. I'll show you why. So HTTP, return the right code to begin with. If you aren't familiar with HTTP return codes, here is a quick cheat sheet on what you should be looking at. But it's really actually, it might seem very obvious, but it's actually very easy for you to forget to add the right code. So in this example, I've got little Express server and they're both 2 API routes. The top one, I'm returning an error hash in this case with an error message, which is great, but I'm forgetting to set the HTTP status, which I'm doing correctly in the second example on the bottom. It's very easy to do this because most HTTP servers, when you try to send something back to the client, will automatically assume you're trying to send like a 200 response, as in something succeeded. So you really have to put some thought into this for most servers to ensure that you're sending the right code. It's very easy to forget this. Next, we should always try to return something. The example on the right here is what we return when you try to delete a particular customer. Now, just returning the status 200 can be enough indication of like, oh yeah, the operation succeeded. However, to get that real developer joy, you should try to add some more information here. So in this case, it gives me the ID of the customer that was deleted, the object type, and even just like a little deleted true thing. This is an absolute confirmation for me as a developer to say, hey, the request that I made, which is to delete this thing, absolutely succeeded. This is especially good later if I want to look at my logs and I want to find my logs by this person customer, without having to look up the request. I can only look at the responses and I can find them very easily. Next, be descriptive. So let's look at that original terrible error message and let's build it up and make it better. First things first, correct status code. We talked about that. This is now a 404 rather than a 200. Next, let's actually wrap the message, the error, inside an error object. This way, most auditing and logging services like Sentry or Datadog will look for something like an error object within your response to be able to determine whether this is really an error or not. And let's change that terrible error message into something which is a little bit more useful. So in this case, customer not found. Okay, this is already a lot better. We have a bit more understanding of what's going on, but still not great. You have to be helpful when it comes to the error messages. So instead of just saying customer not found, let's actually say which customer was not found. This is particularly useful if you have like a lot of requests or things are going wrong, rather than the one on the left gives me no indication or clue where to start looking, whereas the one on the right tells me exactly which customer I can start checking out, and I can start my investigation from there. But we can be better. We can do better. We can be even more helpful. So this particular error of customer not found is actually one of the most common errors you would find with the Stripe API. It's so common, in fact, that we tried to be a little extra helpful by inserting some extra information. So on the API side, we have all the information that a developer probably needs to be able to fix whatever the problem is. And it's absolutely maddening how a lot of APIs do not give that information. In this case, we have a very simple case of customer so-and-so was not found. A similar object exists in live mode, but a test mode key was used to make this request. Now, immediately, rather than having to look up this customer and debug my code, the error message tells me exactly what went wrong and how to fix it. It didn't work because I used the wrong API key. I used a test mode key rather than using a live mode key, or I tried to grab a production customer when I was trying to actually get a test mode customer. Immediately, this cuts down my debugging time from anywhere from 10 minutes to an hour to less than a couple of seconds because I know exactly what went wrong. In the case of 500 messages, it's a little bit of the opposite, where while you want to be extremely transparent with your 400s about what went wrong and how to fix it, less so with 500s. Because for a 500 request, the last thing you want to do is put out a whole stack trace of exactly what went wrong, because you could be leaking information you really don't want to use. You don't want people to see. As an example of this, a little while ago, there was a Stripe user who found lots of suspicious activity on their account. After a little bit of investigation, they found that their live API key had been leaked. If you're unfamiliar, if your live API, Stripe API key leaks, then bad guys can do lots of very terrible things on your account, all sorts of fraud. And after some investigation, he found that he was using a PHP server to power his service, but the PHP server was still set in dev mode. And what it then does is that when it encounters a 500 error, it very helpfully renders a page with a full stack trace, and at the bottom of the page, a full dump of the entirety of the environmental variables, including the Stripe API live key. So be extremely careful with this, with what you put in your 500 messages here. So like I said, don't say your full stack trace, but also don't give too little, like just saying server error. That's not super helpful in the same way that error we first encountered is not super helpful. Instead, give something that for your user, the developer, to go on. For an example would be to send it to a status page if you have one, or say like, hey, we're on it, or give like a contact email address of your support team or whatever. Give them some way to be able to fix or to look into this, because if you see just server error, and this happens many, many times, can be very worrying to developer, particularly if the service that they're using, your API, is very critical, like your payment system. So again, my 4 rules of API errors: send the right code, be descriptive, be helpful, and be empathetic. Next up, I want to talk about how we would put it all together. So here is an example of an error message, a real error message you would get from the Stripe API. It has the right code. We have a message which is very descriptive. We even have a link to the docs URL, so you can find out more about this. And at the bottom in the headers, we have a request ID, which I know because it has REQ_object prefixes. This is something that I can actually take and paste it into the Stripe dashboard, and it'll give me an exact representation of the request and the response objects. And finally, it's got a Stripe version, which is essentially the API version. So this is everything that I would need to be able to debug this further. And the great thing about this and spending some time on making your error messaging better is that it makes it so much easier for your developers, for your users, to self-serve. No longer will they have to contact you or your support team with problems. They can fix it themselves as long as your error message gives them the tools to do so. Next, let's talk about design patterns. Now, what are design patterns? Design patterns are the things you should be thinking about before you write a single line of code within your API. This is how you think about who your audience is and what exactly it is you're trying to convey to them. So you need to understand the humans behind the API, understand the humans, what they want to do and how they want to do it. So in case of who's the intended audience, is this meant for beginners? Is this meant for more senior? Is this meant only for Java developers? Is it only for Node developers? The shape of your API might be different depending on those factors. You want to think about how customizable you want the API to be and how much accessibility are you willing to give up for that customizability. To demonstrate that, let's look at this graph of API power versus API complexity. On the bottom left-hand side, we have something that's low power and low complexity. This is an API that does perhaps one thing and one thing well, which is like the happy path. But the second you stray off it, if you have other requirements, you're kind of out of luck. You can't really do much there. Whereas the flip side is something with high power, high complexity, where the API almost acts as a middleman towards your own backend service, but it's extremely complicated to use. You need lots of documentation, and it's very difficult to get started with this. So you have to kind of make the decision, do you want to have this happy path experience where like you can't do much, but the one thing it does well, or you want full developer control? The problem with full developer control is that, like I said, for new users to jump in, it's going to be very difficult. You kind of want to be somewhere in the middle for this, ideally, but again, it really depends on who your intended user is and how much control you're willing to give. Because most APIs kind of start from the bottom left-hand corner, and over time, they kind of creep up in power and complexity, which is fine for the users who are growing with you, who are requesting that extra power and complexity, because they grow with you, and for them, it's not that big of an incremental change. But if you end up in the top right-hand corner and you have a new starter who doesn't know anything about your API and did not grow with you, it can be unsurmountable, and it can be really, really difficult for them to catch up. Last thing I'll say about this is that this is very much a one-way street. It's not too difficult to go from low power, low complexity to high power and high complexity, but going the opposite way is almost impossible without any kind of rewrite. So think very carefully about where you want to be on this graph, what your API looks like now, and where do you think your happy place is. Another example of design patterns is consistency within your API. And the best way to demonstrate that here is, again, the Stripe API, where I can post to V1 payment intents to create a payment intent. I can update a payment intent by passing in an ID, and I can get a specific payment intent by routing a GET request at that ID. But another nice little quirk that they have is that if you do get V1 payment intents and you don't provide an ID, it actually returns you a list of the payment intents that you would have. This isn't necessarily part of the RESTful spec, I don't think, but it's a nice little thing to have within your API. Now, the thing is, once you have this kind of like helper method, you need to be consistent with the rest of your API. As a user of the API, if I saw that and then tried to do get V1 customers and I did not get a list of customers, instead of just got an error, I'd be annoyed because you're not being consistent. Your API doesn't work the way I expect it to. The benefit of being consistent means that your user only has to learn a small part of your API and how it works, and they can automatically adjust those learnings and apply it to the rest of your API. So your time to like ramp up and get used to and start integrating with API is massively reduced if you are consistent and intuitive. Which, speaking of being intuitive, also a huge factor with your design patterns. So as an example, here I have a pull request to this api.example.com. Here I'm creating a customer. I give it a name, an email, and an address, and I get back a customer object with all those things, which is nice. But let's say that later I wanted to update that user. So I pass in, I go my curl request to example.com for customers and the ID. I just want to change the address. But then I get back this response where the address was changed, but wait, both name and email are suddenly undefined. What happened here? Well, in this particular API, as a bad, non-intuitive bad API design pattern, it just assumed that if I did not pass in name and email in my update call, that meant that I was trying to unset the name and email. Now, this is technically correct, but is also extremely frustrating. This is clearly not what I wanted to happen. And any API that does this is absolutely terrible in respect. Obviously, I didn't want to unset name and email. Why would I ever want to unset name and email unless I specifically asked to do it? But this is one of those examples of this is a non-intuitive, if not correct. And this is a thing that you need to really think about, like, hey, who is the consumer of my API? How would I feel if I tried to do this and got this kind of result? Which is kind of the whole point of this whole talk of like being more human, is that we, like in most things, we need to treat others the way we want to be treated ourselves. And in particular, when it comes to APIs, you need to think about the people behind who are actually doing the integrating. And think about yourself, how would I want to interface with an API and how would I want it to be treated? That's all I got. Thank you very much.